In this lesson you will learn how to calculate the volume of 7 different geometric figures. The first figure is a cube, and the formula is volume is equal to s cubed. S represents each side, and since each side is the same in a cube, it doesn't matter which value is given. In a rectangular prism, there are two formulas, B times H or L times W times H. So LWH is length, width, and height. B represents the area of the base. You want to think of your base as one of them being the ceiling and the other being the floor. So on this picture, the floor would be this side right here. So this is one base, and the ceiling would be this side right here. So capital B represents the area of either the ceiling or the floor. When we get to the triangular prism, there is only one formula, B times H. B also represents the area of the base, and on this figure, if you had to shade the ceiling and the floor, you would have to turn this figure on its side so that this is the floor and this is the ceiling. So these two triangles are your bases. The volume of a pyramid is 1/3 base times height. And once again, capital B represents the area of the base, and on a pyramid, capital B is the floor. So the area of this face would be the base. Cylinder's formula is volume equals pi r squared h. R represents the radius and h represents the height. Sometimes the height is shown here. And the height will always make a perpendicular angle or right angle with the circular base. For a cone, the formula is 1/3 pi r squared h. R is the radius and h is the height, and once again the height forms a right angle with the base. And the last formula, sphere, the formula is volume equals 4/3 pi r cubed, where r is the radius. So the directions are to find the volume, and for all of these problems I'm going to solve them the same way. The first thing I do is I look at the shape and I determine which figure it is. And for this one, we have a cube. And the formula for cube is s cubed. So once I determine my formula, I look at all of the variables in the formula, which in this case is just an s, and I identify s as being 3.1. So I have my variable identified. I go to my volume formula of s cubed, and I substitute 3.1 in for s. So 3.1 cubed is the same as 3.1 times 3.1 times 3.1. So let's start with the first two. So the directions are to find the volume. And for each of these problems, I will solve them the same way. The first thing I do is I identify the figure. For this one we have a cube, because all of the sides are equal to 3.1. Next I write the formula. Volume of a cube is equal to s cubed. And then the variable in the formula is only s, so I identify s as being 3.1. And once I identify the variables, I substitute them into the formula, 3.1 cubed, and 3.1 cubed is the same as 3.1 times 3.1 times 3.1. So starting with the first two 3.1s, I'll multiply them out on the side. And I get 9.61. I multiply 9.61 times 3.1. So that my volume is equal to 29.791, and the units are in centimeters, and volume is always in cubic units. So the answer is 29.791 centimeters cubed. For number 2, the first thing I do is identify the figure, and this is a rectangular prism. And to find the volume of a rectangular prism, the formula, there are actually two formulas. One is length times width times height, and the other one is base times height. For number 2, the first thing I do is I always start off by identifying the figure. And in this picture we have a rectangular prism. And the formula for the volume of a rectangular prism is length times width times height, or base times height. So starting with the first formula, and you don't need to do both, but I'll show you both. Length times width times height, I'm going to make the length 6, this one right here, the width 1.2, and the height 14. Don't worry if you mix up the length and the width, you'll still get the same answer. So when I substitute these values into the formula, I have 6 times 1.2 times 14. So starting with 6 times 1.2, I know that 6 times 12 is 72. So with the decimal, it's 7.2. And if I take 7.2 times 14 and multiply that out on the side, I get a volume of 100.8 cubic feet, or feet cubed. So if you had chosen to use the second formula, base times height, we know that the height is 14, but to find the base, B represents the area of the base. And again, you want to think of your base as being the floor or the ceiling. So if I drew in the floor, it's this rectangle here, which has an area of 1.2 times 6. So 1.2 times 6 brings me back to 7.2. So when I substitute these values into this volume formula, I have 7.2 times 14, which we already know is 100.8. So either formula is fine to use. They both give you the same answer. Always make sure you write your units, and that when you're finding volume, you always write it in cubic units. For number 3, this figure is a triangular prism. And the reason why it's a prism and not a pyramid is because you have two bases. Think of if you turn this figure over on its side, it would stand up and have a ceiling and a floor that are the same shape and parallel to each other. So this is a triangular prism. And the formula for the volume of a triangular prism is base times height. And the height is the distance from the ceiling to the floor. And that would be 20. So this is our height. Now the base represents the area of this shaded triangle. And to find the area of a triangle, we take 1/2 base times height. So now I'm going to change my b to a lowercase b to represent the side of the base. Base and height are perpendicular to each other. So the 13 serves no purpose in this problem. Be very careful of that. Sometimes numbers are given that aren't needed for the formula that they're asking you for. Other times they may not give you all of the numbers that you need. So capital B is equal to 1/2 times 12 times 5. And so I have 1/2 times 60. 5 times 12 is 60. And half of 60 is equal to 30. So when I substitute these values into my volume formula, I have 30 times 20, which is equal to 600 meters cubed. Volume is always in cubic units. For number 4, this is another triangular prism, because this triangle here and this triangle here are parallel to each other. So these two sides are like your ceiling and your floor. So this is a triangular prism. And once I identify the figure, I write the formula, base times height. And the height is the distance between the ceiling and the floor, which is 15. And capital B is the area of the triangle that I shaded. And to find the area of a triangle, it's 1/2 base times height. And so 1/2 base times height. This 6 down here is the base, and this 4 right here is the height of the triangle. So it's 1/2 times 6 times 4. So the height of the prism, this 15 here, is not the height that's used in the area of the base formula. That number 4 represents the height. So I take half of 24, and half of 24 is 12. So when I find the volume, it's 12 times 15, and 12 times 15 is 180 inches cubed. For number 5, this figure is a pyramid, and I'm going to shade the base. For number 5, we have a pyramid. And the formula for pyramid is volume equals 1/3 base times height. And let's find the base first. The base is the area of the floor. And the floor is this square where all of the sides are equal to 6. And to find the area of a square, it's side times side, which is 6 times 6. So B is 36. Now to find the height is the segment from the vertex, this point on top, straight down to the center. So this measure is not given, but when I extend it, for number 5, we have a pyramid. And the formula for a pyramid is volume equals 1/3 base times height. So in this problem, I'm going to find the base first. And the base is your floor. And the base, we want the area of this square. And we know that the sides are equal to 6, and to find the area of a square, it's side times side. And since each side is equal to 6, it's 6 times 6, which is 36. So our capital B is equal to 36. Now the height is actually not given, because the height is the distance from this point here, which is called your vertex, to the center of the base. So this value is not given. If I extend this out to where this red line is given, I have a right triangle. So if I take this right triangle and draw it underneath, we have a hypotenuse of 5 and a side of 3. And the reason why the side is 3 is because this length is 6, and this point here is in the middle of the square, so it's half of 6. We're looking to find this length. So to find this length, I have a right triangle, so I'll use Pythagorean theorem. A squared plus b squared equals c squared. So sometimes not all the numbers are given, you have to find them using a different formula. So we have 3 squared plus h squared So we have 3 squared plus h squared equals 5 squared. The 5 has to be the c because it's the hypotenuse. 3 could be either a or b. And if we square all of the numbers, we get h squared is equal to 16 and h is equal to 4. So to finish this volume problem, I have 1/3 times the base of 36 times 4. And if I cancel the 3 and the 36 to 1 and 12, I have 12 times 4, which is equal to 48 millimeters cubed. For number 6, we have a cylinder. And the formula for the volume of a cylinder For number 6, we have a cylinder. And the formula for the volume of a cylinder is pi r squared h. So once again, I identify the radius and the height, all the parts of the formula. I'm going to leave pi in the problem, and I see that I have a diameter of 18 feet. So that means that the radius is half of that, so my radius is 9. 6 is the height. So when I substitute these values in the formula, I have pi times 9 squared times 6, which is pi times 81 times 6. And on the side, if I multiply 81 times 6, I get 486 pi, and then I have to include the units of cubic feet. Number 7 is a cone. And the formula for the volume of a cone is 1/3 pi r squared h. So I want to identify the radius and the height. So the radius is given. The radius is 6. The height is not given. This length here is the height. The height goes from the vertex, this point up here, right down to the middle of the circular base. But what we do have is a right triangle. So once again, I'm going to use the Pythagorean theorem to find my height. So I have a hypotenuse of 10, and one of my sides is equal to 6. So writing the Pythagorean theorem, a squared plus b squared equals c squared. I have 6 squared plus h squared equals 10 squared. So we have 36 plus h squared equals 100. And if I subtract 36 from both sides, I get h squared is equal to 64. Take the square root of both sides, and I get a height equal to 8. So my height is 8. So when I substitute this in the volume formula, I have 1/3 times pi times r squared times the height, and I can write this out as 1/3 times pi times 36 times 8. So I'm going to put all of these numbers over 1, and the 3 can reduce with the 36 to 1 and 12, so that I just have pi times 12 times 8, which is equal to 96 pi. Our units are meters, so cubic meters. 96 pi cubic meters. For number 8, this figure is a sphere. And the formula for the volume of a sphere is 4/3 pi r cubed. And the only variable that I have to identify here is my radius, which is given. The radius is 12. So once I have all of the variables for the formula, I just go ahead and substitute that in. So 4/3 times pi times 12 cubed. And instead of multiplying out 12 cubed, what I'm going to do instead on this one is I'm going to rewrite 4/3 pi, and I'm going to write out 3 12s. Because this 3 will cancel with one of the 12s here, and it's easier to see that when you write your 12s out versus if you multiply out 12 times 12 times 12. So we have 4 times pi times 4 times 12 times 12. So this 4 and this 4 multiply to 16. This 12 and this 12 multiply to 144. So coming up on the right side of the screen, we have pi times 16 times 144. So underneath, I'm going to multiply 144 times 16. So that I get a volume of 2,304 pi yards cubed.